Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this particular video, today we will be learning BJT characteristics. Now in these BJT characteristics, before learning these BJT characteristics, we will have to learn some few concepts which are related to the BJT terminals and its operation. That is nothing but CB, CE and CC mode of operation of BJT, and then we will be learning few concepts which are related mathematical expressions of current and its relationship with the terminals of the BJT, and then we will move towards the exact characteristics of the BJT. So this is the agenda for our video. CB, CC and CE mode of BJT, that is the first. Then current voltage relationship, this is more or less mathematical, and then we will be learning for input characteristics of BJT, and then we are going for output characteristics of BJT. So the simple calculations, with this simple calculation we will move further for CB, CC and CE mode of BJT operation. CB, CC and CE mode of operation of BJT. Now we will start with CB mode of operation. Question arises in your mind that what exactly CB? What is its full form? CB means common base configuration. So we will say that this is Now what does it mean exactly? Common base means base is common for both input as well as output of BJT circuit. Now we will draw this circuit and then we will analyze what it will be the input current, output voltage and input voltage, and how we'll be getting different circuit with its characteristics. Let us see the fact that this is two-port network, and where I'm getting input voltage over here, output voltage over here, right? Input current is this one, let's say I. Output current is this one, let's say IO. Okay, now let us consider this particular terminal, this terminal and this terminal. These are three terminals, and we will paste our BJT with the proper orientation such that your base should be common for both input as well as output. Now here input, another terminal which is negative, here positive terminal of input, here positive terminal of output, and here negative terminal of output. Negative terminal of input as well as output is common connected to one particular node, and that I will connect to the base of BJT. Okay, and that's why it is called as common base. Now question arises, what will be your input and what will be your output? So in common base configuration, I will say I will form a transistor such that this is the common, and now we will move further for symbolic representation of BJT such that I have completed my circuitry with one single BJT, right? Now one question is remain unanswered, that is where we'll have to put the arrow, right? So if I'm considering the common base configuration, then we will have to have the emitter as your input and collector as your output. So this will be your representation. So this complete configuration is called as common base configuration. Now in this particular case, we will have to learn what will be the input relationship with current and voltage output relationship with current as well as voltage. So we will write this as II is nothing but emitter current. Vi is difference between the potential at emitter and base. So I can say that Vi is equal to VEB, right? For II and IO as well, we will give another Namakarant. As far as DC characteristics are concerned, II is an emitter current, so it is represented by capital IE, and IO is a collector current, it is represented by capital IC. We will learn the relationship between IC and IE in the second agenda of this video. Vi is equal to VEB, and that is nothing but emitter to base voltage. VO is nothing but collector to base voltage. So here we can write V. So here we can write VCB. Simply, so we have got the what is current and what is voltage at input as well as output side. So we will give the Namakarant for the terminals. This is the base, this is emitter, this is collector. So we have completed the CB configuration. This CB configuration is not generally used for amplifier, right? So keep this in mind that we will learn few characteristics of CB in the next slide. Now, what is the characteristics of CB? Common base is having very low input impedance. It is also having high output impedance. It is also having very high voltage gain. But it is having very less current gain. Coming to the part of current gain, we will learn in the next agenda of this video what exactly the current gain relationship, that is called as alpha beta relationship between the BJT terminologies. When we are moving for the next characteristic, that is fifth characteristics, I know that voltage and current multiplication is nothing but the power, and power is very important factor when we are designing particular circuitry, especially electronic circuitry. So here less current gain and high current gain will deliver moderate power gain. So these are few characteristics of CB configuration of BJT. In a short while, we will learn what exactly that voltage gain, what exactly that current gain, and how we will be getting input and output impedance when we will move further for the next few videos. Now this is the time to learn CC configuration of BJT. Now when we are learning for CC configuration of BJT, we spend a lot of time for CB configuration in this particular video. So same way, when I'm going for CC configuration, it gives us the full form common collector configuration. So CC means common collector. Now you can easily draw this particular circuitry and you can easily find out what will be your input current, input voltage and output voltage. So what you will do, you will take a short span of break, and in break you pause this video and draw this circuitry along with me and then come back. Now see, this is the circuit. Maybe your circuit is also correct, same as that of this one. I have configured my BJT such that collector is now common for both input as well as output. Base is the input terminal and emitter is the output terminal. So I will get input current is IB, output current is IE, output voltage is VEC, difference between the potential of emitter terminal and collector terminal. VI is VBC, difference between the potential between the base terminal and collector terminal. Now we will move further for whether CC is used for amplification or not. So the answer is no. Again, in this second configuration as well, I cannot work this CC configuration as completely amplifier. Why? This is because if you see the voltage gain, then this voltage gain is very less. If you compare the current gain, then current gain is very high out of these three configurations. If you compare voltage and current gain simultaneously, then your power gain is not high, it's moderate. So these are the characteristics, and on the basis of these characteristics we are saying that this is not used for as an amplifier. Let us again come to the part of characteristics of this CC configuration. First characteristic is it is having very high input impedance. This is very important aspect of this CC characteristics we are using in so many circuit, that is called as buffer circuit. So I am making a star, and that we will incorporate this particular characteristics we will incorporate when we will use this circuit called as buffer. High input impedance. Second is having very low output impedance. Third one, it is having high current gain. And fourth one, it is having low voltage gain. Again, with these two facts, current voltage relationship, high current gain, low voltage gain. So we'll be getting moderate power gain. These are nothing but the 5 characteristics of CC configuration of BJT. Now, when I'm learning for CC configuration of BJT, both CC as well as CB configurations are used as a buffer circuit. So generally we are using the CC configuration as buffer circuit. because of this characteristics. Now we will move further for the third configuration of BJT, that is called as CE configuration, which is very important for amplification. What do you mean by CE? Easily, common emitter configuration. Now without wasting much time, you just draw this circuit and write input output voltage and current what it is. So this is the circuit, and input current, output current, input voltage and output voltage. Maybe this is very same with respect to your circuit and all these current and voltages. Now question 1 remains same, whether I can use this kind of circuitry with this kind of configuration, I can form a circuit called as amplifier or not. Answer is yes, absolutely. So I will write it over here. I can use this configuration can be used as amplifier. So especially for amplification purpose, we are using more commonly common emitter configuration of BJT, whereas emitter is common for both base as well as collector, where base is the input terminal and collector is nothing but output terminal, where we are forming a load and from where we'll calculate the load voltage and load current. So why not to understand the characteristics of CE mode as well? The first characteristics is, the beauty of this CE mode is we are having all the things are moderate, right? So input resistance, output resistance, in voltage gain, current gain, all the things are moderate. So benefit of this moderate voltage gain and moderate current gain is will be getting high power gain. So all the characteristics are given by me, so you just have to write it on your book without looking at this particular video. Pause the screen for 1 minute and show your talent. So now, writing by all these 5 characteristics, you may be thinking that you are very talented, but don't think in that way. One property is yet left, and that is very important. CE configuration gives you 180-degree phase shift. See this circuit where we are giving input in this AC signal, where first is half cycle is positive and second half cycle is negative, whereas whenever we are going to amplify one particular signal, which is input signal, at the output stage we will be getting the phase shift in the form of 180 degree, where your first half cycle will be negative and another half cycle will be positive, where we are getting this phase shift is nothing but 180 degree. And that's why the beauty of this CE configuration is there in your amplification process. If you ask whether it is possible to have the CB configuration and CC configuration with 180 degree phase shift or not, the answer is no. It is not possible to get 180 degree phase shift in your CC or CB configuration. There I can say your phase shift is 0 degree. So that is also one of the characteristics in CE and CB, but generally as we are giving the input, the same way we are getting the output, so there is no need to express that as a characteristics of CB and CC configuration. Now we will say that we can use this CE as your amplifier. So especially we are using the amplifier because of two characteristics. One is moderate current gain and moderate voltage gain, and because of which we are getting moderate power gain, and because of which we will be getting high power gain. And this is the very special mode of operation of BJT. So we have completed our first agenda of your video. Now we will move towards the second agenda of our video. Now we have completed the first agenda of this video series. So in this next video, we will learn the second agenda and forward. So thank you so much for watching this particular video. I hope you have learned a lot from this particular video. Learn more and more ADC along with me. So stay tuned for that. For that, you have to subscribe our channel of Ekeeda. Thank you so much.